Okay, so for inverse variation, make sure you remember the formula, y equals k divided by x. And so we're going to plug in for y, that's 6. Plug in for x, that's 4/3. I think you'd multiply both sides by 4/3. Cancels over here nicely. So you get k equals 24/3, which is 8. So my equation, it says find the function. So my function would be, again, you're going to plug that in to k here. So it's going to be y equals 8 divided by x. That will work for the rest of this problem. Find y when x is 4. So y would equal 8 divided by 4, which is 2. Okay, same thing here. So you're just going to plug and chug here. Y equals k divided by x. So you plug it in, it's going to be 10 equals k divided by 6, so 60 equals k. So my equation is y equals 60 divided by x. That's the function. Plug in 4 for x, so y equals 60 divided by 4. I think that goes in there 15 times, so y equals 15. It's 15 there. So this is direct variation. Make sure you know the formula, y equals k times x. Use x and y from this one. So 6 equals k times 1/2. Multiply both sides by 2. Get k equals 12. So my equation is y equals 12 times x. Plug in y is 24. So 24 equals 12x. Divide by 12. Get x equals 2. For the inverse variation, so this time we're plugging a lot of plugging and chugging. Y equals k divided by x, right? So this will be 2 equals k divided by 1/4. 2 times 1/4. So well, I guess we're going to multiply both sides by 1/4. So you get 1/2 or 2/4, which is 1/2 equals k. So my equation is y equals, well, I guess identify the constant. It's 1/2. You got it. I was going to find the equation, but we didn't need it there. So graph each function. So if you want to do this, so this would be, so the parent function would be like 3/x here, right? So let's just graph the parent function. So we know that starts with, y equals 0. We know it goes through, so it has x equals 0 as my vertical asymptote. And typically that function, again, I'm just kind of roughly gauging it. It looks something roughly like this, first and third quadrant, right? That's the dotted line. But we're, of course, talking about negative. So what's happened is the function reflects over the x-axis. So that first quadrant now is in the third quadrant. So this is the actual graph, right? And again, this is the actual graph that down in 4 reflects up to the second quadrant. So the parent function is in first and third, but this one has reflected, so it's in second and fourth quadrants. This one, it takes the parent graph, again, start with the parent graph, y equals 0, y equals 0, x equals 0. And we're going to move it to the left 2 units and down 1 unit. So if I move to the left 2 units, my new asymptote is x equals -2. If I move it down 1, my new asymptote is y equals -1. I would consider finding the x and y intercepts. It might help us here if you're having trouble. Let's just find it just for fun. So plug in x equals 0 to find the y-intercept. That'd be 4/2, which is 2 minus 1 is 1. So it should cross right about there. Find the x-intercepts. Plug in 0 for y. So you get 0 equals 4 over x plus 2 minus 1. So 1 equals 4 over x plus 2. Multiply both sides by x plus 2. So x plus 2 equals 4. X equals 2. So it looks like it crosses about there. You can tell this graph looks roughly like this. And then it can't be up top because it would approach the asymptote, so it's got to be down low. It's got to be this one. very crazy for the translation that gives these asymptotes. So I want to move it to the left 3 units, because normally it's at 0. I want to go up 7 units. It's going to start with y equals 2 over x. So I want to go to left 3 units, so I'm going to say plus 3 down here. I'm going to say go up 7, so I'm going to say plus 7. You got it. The formula is y equals a over x minus h plus k. That's like inside the parentheses kind of stuff there. Sketch the graph, simplify. So right away we know we have a hole. The ordered pair of the hole is going to be -3. And my new function is y equals x minus 1, right? So if I plug in -3 there, I get -4. So at -3, -4, let's try to plot that point. Open circle right there, that's our hole. The y-intercept is, this is linear. Y-intercept is -1. Slope is +1. Looks like it goes kind of like that. Goes through there. So your line looks roughly like this. Whoops. Hops over that point and keeps it going. Something like that. This one, there's a vertical asymptote. If you go through the progressions at x equals 2. There's a horizontal asymptote at y equals 1. Oops. Sorry, that's a little bit off, but it should be y equals 1 there. There's no hole because nothing cancels. Find the y-intercept, plug in x equals 0, so that'd be +5/2, which is about 2.5-ish, so we're about there. Find the x-intercept, so 0 equals the numerator, the denominator is going to go away, so x equals 5, about here. Right away, you should know the quadrants it's in, so it's going to look like that, and it's going to look like that. You don't have to plug any points. Simplify the expression, so right away you see this guy's going up, it's going to become a positive, it's going to become y squared up top. You can see some of the x's cancel, the 27 cancels, so that's going to be 3 and 2. So I have 3 over 2. 3 of the x's cancel, there's 1 left over in the denominator. It's going to be y to the 7th up top. If it says state the restrictions, x can't be 0, y can't be 0. Let's try factoring this guy and see what happens. So the top left will be x plus 2, x minus 2. Bottom would be 5 times x plus 2. 3 times x minus 2. 12 times x minus 3. And we're going to cancel what we can. X minus 2 cancels. X plus 2 cancels. Oh, this is beautiful. Let's get 12 times x minus 3 all over 5. Oh, all over 15. Oh, that does cancel. I didn't see the 3. That's really 4, isn't it? Right, so this is going to be 4 over 5. So I get 4 times x minus 3 over 5. If they wanted restrictions for the variables, you'd say x can't be -2 and x can't be 2. Don't forget this is division, so you're going to flip this guy. So we get x squared over x plus 1 times x plus 1 equals x plus 1 times x minus 1 over 2x. So we get, or times, why did I say it's a times sign? I flipped it, right? So it becomes a multiplication sign right there. Sorry, x times x minus 1 over x plus 1, and that's being multiplied by 2, I believe. If they ask for restrictions, x can't be 1 or -1 or -2. Finally, a little tougher one to factor here for sure. So I'm going to try guess and check this. So 2x and x. There's only a couple numbers to check, 2 and 1. So if I put 2 there, it's not going to work. I think this might work. Let's see. So the bigger number is negative. So if I put minus here and plus here, I think that works. Now this one, somebody give me 2x and x, 3 and 1. So if it works, I'm guessing it's this one. And it'd both be plus. Let's see if that works. So it'd be 1 and 6 is 7. Yeah, that works. 2x plus 1 nicely cancels. Oh, beautiful. X minus 2 over x plus 3. Restrictions are x can't be negative 3. X can't be 2x plus 1, so it'd be negative 1 half. You can set that equals 0 and solve to get that if you need to. Identify the sum, so I need to add these up. So multiply this by x, multiply this by 3. Let's get 6 over 3x minus x squared plus x over 3x. So I get x squared, negative x squared, minus x plus 6 all over 3x. And I am wondering if that factors, but even if it does, it's not going to cancel with 3x, so probably done at that point. Okay, so I need the same denominator. Right now that the right-hand side has n plus 4 times n minus 4. The left-hand side only has n plus 4. It needs an n minus 4. So I'm going to multiply by n minus 4. So I get 2n minus 8 plus n squared all over n plus 4 times n minus 4. Let's try to factor this. So this is n squared plus 2n minus 8 all over n plus 4 n minus 4. And I think it might factor. Let's see. So this would be, I guess, 4 and 2. Bigger number is positive, it's negative. I think that would work. N minus 2 over n minus 4. Again, if you need restrictions, x can't be 4, negative 4. I think that's it. This one, x can't be 0 if you need restrictions. Okay, I need the same denominator, so I need this one to be c times c plus 1, and this one needs to be c plus 1 times c. So I get on the left c squared plus 2c plus 1 minus c squared all over c plus 1 times c. Plus 2c, yeah, so this is going to be c squared goes away, so we get 2c plus 1 over c times c plus 1. Denominator c cannot equal 0 or negative 1. So start with parentheses, just get in that habit. This one needs a 3, this one needs a 4. I think they're good on ends. This would be 8n plus 4 plus 6 minus 9n all over 12n. So this would be negative n plus 10 all over 12n. That would be okay. N can't be equal to 0. pretty intense fraction here, so you could do a number of things. My preferred method is just multiply numerator denominator by 10 here. So if you do that, you get 10 plus 10 over 5 is 2. 2 times 2 is 4. You get 14. And if you do that here, 10 over 2 is 5. So 5 times 5 is 25. Minus 10 over 5 is 2. 2 times 2 is 4. So that's over 25 minus 4 is 21. So that's 2/3. This one, maybe multiply top and bottom by c. I think that would be the fastest way. So we get c squared minus 1. Get c plus 1. This simplifies even further. C plus 1 times c minus 1 all over c plus 1 is c minus 1. And restrictions are c cannot equal 0 or -1. We're almost there. Okay. So this one needs, just get rid of everything by multiplying by the common denominator of 6. So distribute that. 6 over 3 is 2, so that'd be 4x minus 6 over 6 is just 1, so that's x. And this is -6. It's easy. 3x equals -6, so x equals -2. Okay, so on this one, we're going to multiply everything by the LCD, which would be 12 in this case, right? So I'll just go ahead and distribute it first, and then we'll cancel. You can do this all in one step if you want. Some people cancel right away. I'll just wait and cancel at the end. So 36p over 4 equals, what's 12 times 15? So that's 1 and 3, 5 and 1, so 180. So 180 over 4. So that should also cancel. It cancels nicely. So this is 2p squared minus 9p equals 180 divided by 4 is 45. So I'm going to make that a quadratic here. So 2p squared minus 9p minus 45 equals 0. And that might factor, I'm not sure. Let's see, factors of -90. So positive negative number add up to be 9. So 1 and 90, 2 and 45, 3 and 30, 4, no, doesn't go to 90. 5 does, 5 and 18, getting closer. 6 and 15, I think. 6 and 9 is, so I think that could work if the 15 is negative. Okay, so I'm using the AC method here. So it's going to be 2p squared minus 15p plus 6p minus 45. So I'm grouping the first two, grouping the second two. So I get, let's see, p times 2p plus 50 or minus 15 plus 3 times 2p minus 15. So I'm going to regroup it as 2p minus 15, and the leftover is p plus 3 there. So my that's not equal to 0, so that's going to be p equals -3. I think that's a solution. You might have to check it in a minute. Set that 2p minus 15 equal to 0. So 2p equals 15. So p equals 7.5. 15 over 2. And yeah, they both work because there's no denominators to worry about that could be 0, right? Denominators are all positive there. So I get my two answers and I'm good to go. Factor this first. So this one is really 2 times x plus 1. This one is really x plus 1, x minus 1. And this one's x minus 1. So my LCD would be, I need an x minus 1 for sure. I need an x plus 1 for sure. I need a 2. I guess I should have put that first probably. I need all those, right? So that's all part of it. So I'm going to multiply by the first one. The 2 and x plus 1 will cancel, so I just get the 1 times x minus 1. And then multiply by the 5 here. The x plus 1, x minus 1 cancels, so like 2 times 5 is 10. And the last one would be the x minus 1's cancel, so I get 2 times x plus 1. So I get x plus 9 equals 2x plus 2. X, if I subtract x, I subtract 2. That's a positive 9, so that'd be 7 equals x. So x equals 7, and that does work because it doesn't make any of the denominators 0. It's not extraneous, at least. This one looks like my LCD is just going to be x plus 1 times 3x plus 1. And distribute here, the x plus 1 is canceled, so negative 4 times 3x plus 1 equals 5 times x plus 1. So we get negative 12x minus 4 equals 5x plus 5. So I'm going to add 12x to both sides, so I get 17x, subtract 5, I get negative 9, divide by 17, so I get x equals negative 9/17, which, if you look at the denominator, that works just fine, so I think that's my answer there. You can see I have the answers posted. Did I get the same answer there? Yeah, negative 9/17, just checking that. Okay, so that's the end of year review. Again, I think we'll have a group quiz coming up next on that. We'll see.